Hello everyone, this is Aparna Shetty from the Department of CSE, AJ Institute of Engineering and Technology. So in the previous video, we have seen how to nest the trie blocks, correct? How to nest one trie block within another trie block and how the catch will be executed. Okay, suppose if the inner trie block does not have its own catch, then the exception of the inner trie block will be handled by the outer trie block's catch. Okay, so we have seen with an example how nesting of trie takes place with an example over here. Okay, so in today's video, okay, I will like to continue with that exception handling. Okay, the remaining part of the exception handling chapter, that is nesting the trie blocks. Okay, a little portion is left of that nesting a given trie within another trie, and next we will discuss throws finally, and at the end we will discuss the Java built-in exceptions. Okay, so let us begin. So we have seen the example of how to nest the trie blocks. Next, let us see this example over here where trie statements can be implicitly nested through calls to the methods. Okay, so see this example over here. We have a class meth nested trie. We have a method static void nested trie. It takes an integer parameter a over here. Within that method now we have a trie block. Okay, here if a equal to 1, okay, that is if one command line argument is used, then you are going to generate a divide by 0 exception. If two command line arguments are used, that is if the value of a equal to 2, then you will generate array index out of bound exception. Okay, then you will close the trie block. You have this catch block which will just handle array index out of bound exception. Okay, it will display a statement describing the exception, and it will display the value of e object. See this main method here, public static void main. Inside this main method we have defined the trie block, okay, where a is assigned the length of the command line arguments. So a is equal to args.length, okay, which will give me the number of command line arguments, and that value will be assigned to a. So if no command line arguments are present, okay, then the value of a will be 0. If a is equal to 0, this statement will generate a divide by 0 exception, which is a type of arithmetic exception. Okay, here if an exception occurs, the remaining part of the trie block will be bypassed and the exception will be handled by this catch block. If an exception does not occur over here, that is if the value of a is not 0, in which case you have passed some command line arguments. Okay, in that case the value of a will not be 0. In that case you just display the value of a and you call nested trie method. You pass the value of a as a parameter to the nested trie. Understand this program clearly. Okay, we know that in every class, okay, the first method that executes is the main method. Now for the main method we have created a trie and a catch block. In the main method, if the value of a is 0, then we will generate a divide by 0 exception. In that case the remaining part of the trie block will not be executed. When an exception occurs over here, directly the control will get transferred to the catch block, which will handle that particular exception. Since divide by 0 is a type of arithmetic exception, it will catch that exception object e. Next, it will display suitable error messages like divide by 0 and the value of the exception object E. Now suppose in the main method over here, if the value of A is not 0, then divide by 0 exception will not occur over here. In that case, you will simply display the value of A and you will call the nested try method with the value of A passed as a parameter. So within a try block, you are making a call to a method nested try. In this nested try method, again you have defined the try block and the catch block. Okay. Within the try block of the nested try method, again, if the value of A that is passed to this method is equal to 1, again you will generate divide by 0 error. Okay. This divide by 0 exception, whenever it occurs, immediately the control will get transferred to the catch block. Since the catch block over here will handle only array index out of bound exception, it cannot handle that arithmetic exception which got generated. So the exception will be passed to the caller method's catch block. Who has called this method? Main has called. So the exception object will be passed to the main method's catch block. So since this catch block now, it can handle arithmetic exception, the exception will be caught by this catch block and it will be handled over here. Now suppose in nested try, if divide by 0 exception does not occur, that is, if the value of A is not equal to 1, then this statement will not create any exception, it will just execute, and this next statement will also get executed. That is, it will test if the value of A is equal to 2. Now if the value of A is equal to 2, then it is true over here. If it is true, you are going to generate an array index out of bound exception. Since array index 42 is accessed, the C array does not have an index of 42. It just has an index of 0 with the value 1. It does not have an index of 42. So when you try to assign value for C of 42 is equal to 99, it will generate an array index out of bound exception. So as soon as an exception occurs, immediately the control will be transferred to the catch block. Since this catch block over here can handle array index out of bound exception, okay, it is taken care over here. It will display suitable error messages, array index out of bound, and it will display the value of E. So that was an example of this program where in the main method you had a try block. Inside the try block of the main method you are calling another method, nested try. Again in this nested try method you are going to define the try and the catch. So in the nested try method, try, if an exception occurs and the nested try method cannot handle that exception, that means if the catch block of the nested try method cannot handle that exception, then the exception will be called to the caller method's catch block. That is the catch block of the main method. So this is how within a method try you will make a call to another method which will have its own try and catch block. Okay, this is one more way of nesting the try and the catch. So the output of this program is identical to that of the preceding example. It is same how we executed the previous example we saw when we pass no command line arguments, when we pass one command line argument, and when we pass two command line argument. We saw how the output was generated. Same output will get generated for this program also. Next topic is throw. Now let us discuss this throw in detail. It is possible for your program to throw an exception explicitly using the throw statement. Now, till now, in whichever example we have seen, okay, the exception was thrown automatically by the Java runtime system. Whenever an exception occurred, an exception object was getting created and it was automatically being thrown by the Java runtime system. If we want to manually throw an exception, then we can do so by using the throw keyword. The general form of throw is shown here, the keyword throw and the throwable instance. The throwable instance must be an object of type throwable or a subclass of throwable. We have seen initially that throwable is a superclass of all the type of exceptions and error. So, throwable instance should be of type throwable or a subclass of throwable. There are two ways you can obtain a throwable object: using a parameter into a catch clause or creating one with the new operator. So, there are two ways in which you can obtain the throwable object or the exception object. We have already seen the first way, that is using a parameter into a catch clause. We saw that the catch clause has one parameter which is of type exception. So, that is an object of an exception type. So, that is how we will get the throwable instance or the throwable object. One more way of getting the throwable object is by creating one with the new operator. The second way of getting the throwable object we are yet to see. The flow of execution stops immediately after the throw statement. Any subsequent statements are not executed. That is, whenever the throw statement is encountered, that is, a new object is created and it is been thrown by the help of a throw statement, the subsequent statements in the try block will not get executed because we are generating an exception and we are throwing an exception. Whenever an exception is thrown, it has to be handled immediately by the catch block. That is why the subsequent statements within the try block will not get executed. Next, let us see this example of demonstrating the throw. We have the class here, throw demo, that is the name of the class. Inside the class, we have defined the method demo procedure. Okay, we have a try block for this method and we have a catch block. Okay, then we end this demo procedure method. Next, we have defined one more method, that is the main method. The main method also will have the try block and the catch block. Now, let me start explaining from the main method. You see that in the main method we have the try block. Inside the try block, we are going to call the method demo procedure. So, the control goes to the method demo procedure. Now, within this method demo procedure, I have one more try block which will throw a null pointer exception. Now, this new keyword is used to construct an instance of null pointer exception. That is, this new keyword over here, it is used to create an object of type null pointer exception. So many of Java's built-in runtime exceptions have at least two constructors, one with parameter and one that takes a string parameter. Okay, the string parameter over there describes an exception. So over here we are creating an object of type null pointer exception, and to the constructor of null pointer exception we are passing a string that is demo. Okay, we have already seen how objects are created, yes or no? Same way here the exception object is created by using the new operator. The type of the exception object that was created is null pointer exception. Since when an object is getting created, its constructor will be called. Here, since we are creating an exception object of type null pointer exception, the particular constructor will be called, and to that constructor you will pass the string demo as an argument. Now since we are throwing an null pointer exception, that exception will be caught by the immediately next catch block. This catch block will catch the null pointer exception, okay, and it will handle it this way. It will display the message caught inside demo procedure, telling that the exception was caught by the catch block inside the demo procedure method. After it displays that statement, next again it will throw E. E is an object representing the null pointer exception. Again it will rethrow the exception. Once it has thrown inside the try, okay, that thrown exception will be caught by the catch, handled, okay. So it is handled by the catch block. Again it is rethrown over here, okay. So throw E will again rethrow the exception. Now when it is rethrown over here, it will be caught by the caller method's catch block. Since main has called the demo procedure method, so that exception will be caught by the catch block of the main method. Since this catch block can also handle the null pointer exception, it is recaught inside this catch block and the value of that exception object will be displayed. So here, as you have passed a string demo to the constructor of the null pointer exception, whenever you are trying to display the value of E, that E will contain the string that you have passed to its constructor. The string that I have passed is demo. So see the output over here. The string that you pass to the constructor will also get displayed over here. So the output will be caught inside demo procedure, and again recaught Java. Since you are displaying the value of exception object E, it will display java.lang.null pointer exception and the string that you passed demo. So in this program here, we are throwing the exception object twice. Once it is caught and handled inside demo proc. Again it is rethrown and it is caught by the main method's catch. Okay. So this is how this particular program executes. So this is how we can throw an exception object explicitly by using the throw keyword. Next topic, let us discuss throws. If a method is capable of causing an exception, that it does not handle, it must specify this behavior so that caller of the method can guard themselves against that exception. So we have already seen what throws keyword will do, right? Throws keyword you are going to use in the method declaration, telling that that particular method will generate an exception, but it will not handle it. So who is supposed to handle that exception? The caller method will handle it. Okay, so it is used to specify the callers of the method, okay, that particular method will throw an exception, and hence they can guard themselves against that exception. A throws clause lists the type of exceptions that a method might throw. Now, using the throws keyword in the method declaration, we can list many types of exceptions. Okay, we can list 2 or more types of exceptions that a method might throw. So a method might generate 2 or more types of exceptions. Okay, so all the type of exceptions that method will throw, such exceptions you can list it in the throws clause. Exception that a method can throw must be declared in the throws clause. This is the general form of a method declaration that includes a throws clause, type, method name, parameter list, the keyword throws, exception list. Exception list is the list of exception that this particular method is going to throw. Opening of the braces, okay, body of the method, and closing the braces. So return type of the method, okay, method name, parameter list. This is the method declaration or the definition of the method. Okay, return type, name, and the parameter list. So after you specify the parameter list and close the bracket, you need to use the keyword throws, and here exception list is a comma separated list of exceptions that this particular method will throw. We will understand it clearly when we go through the example. Now, this program contains an error and will not compile. Let us see what is the error in this program. Here, class throws demo. Inside that you have one method, throw1. Now, in that method, we are going to display inside throw1, and we are going to throw an exception object. So, throw new illegal access exception, okay, and the string that is passed to illegal access exception is demo. Here we have already seen the throw keyword. This new operator will generate a new exception object of type illegal access exception, and it will throw it. Okay, so since in this throw1 method we have not defined the try and the catch block, okay, here, but the exception is being created and it is being thrown, but we are not handling that exception. Okay, that is why this program contains an error and it will not compile. So next is the main method, which will just call the throw1 method. In the throw1 method, you are going to create a new exception of type illegal access exception, and you are going to throw it, but you are not handling this exception. Whenever you are throwing an exception explicitly or manually by using the throw keyword, you need to handle that exception in your program. The default handler of the Java runtime system will not handle the exception if you manually throw an exception. That you have to remember. Let us see this next example here. Here we have the class throwDemo. Inside this class, I have one method throw1. Next, throws illegal access exception. Here, the throw1 method will throw an exception of type illegal access exception. System.out.println inside throw1, throw new illegal access exception with the string demo. Okay. Next we have this main method. Inside the main method we have the try. Okay. In the try block you are going to call the method throw1. Next you have the catch block for that particular try block. Okay. Which will catch illegal access exception. Okay, and it will handle it. Now let us start from the main method here. In the main method we have the try block and we have the catch block. In the try block I just make a call to throw1 method. So the control goes to the throw1 method. In the method signature of throw1 you are going to tell the caller of the method that throw1 is going to throw an illegal access exception. So this throws keyword tells the main method which has called throw1 that throw1 will throw illegal access exception. This throws keyword you have to use whenever this particular method will generate and will throw an exception, but it will not handle it. Here the throw1 method, inside throw1 you are going to generate an exception object of type illegal access exception and you will throw it. But you are not handling this exception inside the throw1. That is why you have to specify the caller throws illegal access exception, telling the caller that throw1 will throw illegal access exception and it must be handled by the caller method only. So the caller method catch will handle that illegal access exception which is been thrown by the throw1 method. So basically the throws keyword you have to use in the method signature, telling the caller method that it will not handle the exception. The exception is supposed to be handled by the caller method only. Here throw1 will throw the illegal access exception, but it is not handling it. Okay, so using this throws keyword, here you are telling that the main method which called throw1 is only supposed to handle the illegal access exception. So that was about this program. The output generated by running this example program is inside throw1, that is this statement got executed. Next, exception was generated, that exception was passed to this catch block and then this catch block executed, this statement got displayed, caught, and the value of E is java.lang.illegal access exception and this string that you passed to that exception, that is demo. So this is the output of this program. Next, let us go through one more example here. Class throws demo2. Okay, inside this class we have a method. The name of the method is called method, which will throw input output exception. So throws input output exception. See the next statement over here. Buffer reader, the object of buffer reader you are creating, okay, for input stream reader. So for the input stream you are creating a buffer and that buffer you are representing by the buffer object BFR. Okay, so you are creating a buffer for the standard input stream. Next, you call the buffer dot readLine method. Okay, you call the readLine method for the buffer object. Okay, over here, input output exception is generated over here. Okay, so that exception will be thrown to the main method. Here, whenever you are trying to access the standard input buffer, okay, and buffer dot readLine method when you call. Okay, here if the buffer is busy or if the standard input is busy, then if you call the readLine method for the buffer, it will throw an input output exception. Okay, so that exception will be caught by the caller method and it will display the message regarding the exception. So the throws demo 2 method, okay, will generate an input output exception whenever you are trying to read from the buffer. Okay, that exception will be caught by the caller method's catch and it will be handled. Okay, here next we will see finally. Finally creates a block of code that will be executed after a try-catch block has completed and before the code following the try-catch block. So after the exception has occurred and it has been handled by the try-catch block, so once the try-catch block completes, the finally block will be executed, okay, before the code following the try-catch block. The finally block will execute whether or not the exception is thrown. If an exception is thrown, the finally block will execute even if no catch statement matches the exception. So even if that try does not have any matching catch to handle that exception, even in such cases finally block will execute. Now what code we'll have to put inside finally? Now whenever an exception occurs, okay, the resources that you have been allocated may not be deallocated properly, because when an exception occurs, okay, the program execution halts. In that case, the resources, like suppose if you have opened a file before the exception occurred, okay, once an exception occurred, the program execution stops and you have not the code to close the file, okay, might be bypassed in the try block. Okay, the code which specifies that the file has to be closed, okay, might be bypassed in the try block. So the file may not be closed. In such case, you can put the statements to close the opened file inside the finally block. So deallocating or closing of all the resources, you can do it inside the finally block. The finally clause is optional. Okay, it is left to the user whether he wants to provide finally or not. Each try statement requires at least one catch or a finally clause. Next, let us see this program here. Class finally demo. Inside this class, we have one procedure A method which will have a try block. Inside the try block, we are going to display inside procedure A, we are going to throw runtime exception object. Next, we have the finally block for that try, which will display procedure A's finally. Next method, procedure B, will have a try block and a finally block. Inside this try block, we are just displaying inside procedure B. No exception object is being thrown inside this try block. Okay. After that, we have the finally block telling procedure B is finally. Next, we have this procedure C method, which again has a try block and a finally block. The try block will display inside procedure C, and the finally will display procedure C is finally. Next, see this main method. In the main method, I have a try and a catch block. The main method inside the try block I just call procedure A. So, whenever we make a call to procedure A, the control will go to procedure A method and procedure A will start executing. So, it will display inside procedure A and it will throw an exception, that is of type runtime exception. Whenever an exception is thrown, immediately the control will go to the catch block. This catch block over here, it will handle any type of exception. E is an object here representing generic exception. So this E can handle all the exceptions. So exception is caught in the catch block. Now inside procedure A, once the exception has been handled, we will execute this finally block. After the exception has been caught and handled, this finally block will get executed. So procedure A is finally it will display. Okay. Once this procedure A method finishes executing, the control will go back to the main method, and next the main method we are making a call to procedure B. Okay, this procedure B and procedure C are called outside the try. Okay, since in procedure B and procedure C no exceptions are thrown. Let us see procedure B. In procedure B try, you will display inside procedure B. Then you will return. Here before the try returns, it finally will get executed. Before this method returns, the finally block will get executed. Procedure B is finally. Next, it makes a call to procedure C. In the procedure C, it will display inside procedure C. So before this procedure C method returns, it will display the finally block. Procedure C is finally. So this is how this program executes. Let us see the output. So first it will display inside procedure A. Since procedure A has thrown an exception and it is not handling, it is not catching it. Okay, so that exception will be caught by the main method's catch. Okay, so before this procedure A returns, its finally block will get displayed. Procedure A is finally. And finally the catch block of the main method, which will handle the exception, will get executed. Exception caught. Next, it will display inside procedure B. Procedure B is finally. Inside procedure C, and procedure C is finally. This is how the output looks like. Okay, here when the procedure A throws an exception, okay, before this method returns, since this method cannot handle that exception, it cannot catch the exception, correct? So before this method returns, first it will execute procedure A's finally, and then the main method's catch block will get executed. So whatever code is inside finally, it will get executed, okay, before the method returns. Here procedure A does not have a catch. Okay, so once an exception occurs, after the try block execute, the finally will get executed, and then the catch block of the main method will handle that exception. So this is about this program. Next, let us go through the Java built-in exceptions. Okay, first type of exception is arithmetic exception. arithmetic error such as divide by 0, array index out of bound exception, array index out of bound, array store exception, assignment to an array element of incompatible type. So that is about array store exception. Class cast exception, invalid casting of the class. Illegal argument exception, illegal argument used to invoke a method. Illegal monitor state exception, illegal monitor operation such as waiting on an unblocked thread. Illegal state exception, environment or application is in incorrect state. Illegal thread state exception, requested operation not compatible with current thread state. Index out of bound exception, some type of index is out of bound. Negative array size exception, array created with the negative size. Next, null pointer exception, invalid use of null reference. Number format exception, invalid conversion of a string to a numeric format. Security exception, attempt to violate security. String index out of bound exception, attempt to index outside the bounds of the string. Unsupported operation exception, an unsupported operation has uncounted. So this was about the built-in exceptions, okay, of Java. So you have to study this built-in exceptions also, okay. You just have to know the exceptions and their meaning, that is what it does. So this is all about exception handling. I hope we are clear with the concepts. If there is any doubts, we will discuss it in the Google Classroom. Thank you.